Welcome friends, in this video we are going to look at Science Paper 2 for the year 2011. So we have question 1 here. Use the information in the table to answer the following questions. So the first column consists of substance, second one conducts electricity when solid, then the melting point per degree Celsius, dissolves in water. So the first substance we have sodium chloride, sulfur, tungsten, wax, and the last one is aluminium. Now A1, name one metal from the table. So we have tungsten, and aluminium. Then Roman number 2, how could you tell from the table that the substance you have chosen in A1 is a metal? So from the given information, we can use the conductivity of electricity when in solid. So if you look at the tungsten, we have yes, then the aluminium also yes. So only metals have the ability to conduct electricity when in solid state. Then the other thing that we can use here to identify this is the melting point. Most of the metals have the highest melting point. If you look at the melting point of tungsten, is about 3,377. Then for aluminium is 660. Then if you look at sulfur, which is a non-metal here, the melting point is 113. So you can use the melting point, even the conductivity of electricity. So we can say because they can conduct electricity when in solid state. Then the second one, you can also use the melting point. So you can just say because they have the high melting point. Then we move on to question B. How can you tell from the table that wax is a mixture? So if you look at the mixture, we are looking at a combination of two or more substances, but these mixtures, they are not chemically combined. Now let's look at the first one, conducting of electricity when in solid. We can say we have no. Then it dissolves in water, no. Now, so we are going to use the melting point. So we have been given the range of the melting point for these mixtures or substances that forms this mixture. And the melting point starts from 35 up to 50. Now, so what has the melting point, the different in terms of melting point, has to do with a mixture. We know that a pure substance, or we can just say a substance or a compound, as long as it's just that one compound, must have only one melting point. So whenever you have a substance with different melting point, as long as there is a different melting point, that is the qualification that that substance is a mixture. So that's what we are going to use here. So say because of different boiling point, not boiling but melting point, then name a compound from a table. So a compound from a table, we have sodium chloride. Then question Roman number 2, explain the meaning of the word compound. So it is a combination of two or more elements that are chemically combined. So the key is chemically combined. So we have the chemical means in terms of the bonding. Then we move on to question. We have question 2. Use the list of separation techniques below to answer the questions that follow. The first one, fraction distillation, simple distillation, use of separating funnel, magnetism, chromatograph, evaporation, and filtration. Choose one method from the list above which can be used to separate. The first one, sand. So you can say insoluble substance from a liquid. So the method that we can use is filtration here. Then the second one, we have ore from water. We are looking at immiscible liquids. So immiscible liquids are those that cannot mix because of different densities. So oil from water, such as cooking oil from water, we have separating funnel. Then here, water from ink has to do with color. Apart from color, solubility. So we have chromatography. Then sulfur. Sulfur is non-magnetic while iron filing are magnetic. So whenever we have non-magnetic and magnetic material, we use magnetism. Then salt from paraffin. Here we are looking at salt and the liquid, so we use evaporation. Go to question 2. 3, element E, whose proton number is 3, is 7, combines with hydrogen to form a gas. The diagram below shows the bonding in one molecule of this gas. So if you go, for questions like this one, you should use a periodic table. So if you go on the periodic table, the element with the proton number of 7 is nitrogen. Then the mass number is 14. So this is our answer here. We have nitrogen. Now, what is the name of the gas? So if nitrogen with the valence of 3 bonds with hydrogen with a valence of 1, and if we use the crisscross method here, we have NH3 as the chemical formula. So this chemical formula is for ammonia. Then for C, write the chemical formula of the gas. So the chemical formula for ammonia is NH3. What type of bonding holds the atoms together in this compound? So since we are dealing with non-metals, we have covalent compound, which is covalent bonding. Or since we have seen that we are dealing with sharing of electrons, so it is covalent bonding. Then state one physical property of the gas that is due to the type of bonding it has. So this question is same as the physical property associated with covalent compound. So they do not conduct electricity. So when in molten or in any state, if you want to give this one in terms of the boiling and melting point, you need to say they do not have, or you can say they have low melting and boiling point. Then F, name another compound which has the same type of bonding, which is covalent bonding. The first one is water. Apart from water, carbon dioxide, carbon monoxide, sulfur dioxide, all these are covalent compound. If you look at methane, which is all of the organic compounds, they use covalent bonding. Then we go to question 4. Use the periodic table to answer this question. give the symbol of the first one, a non-metal used to sterilize water. So to sterilize here means same as to purify. So a non-metal that can be used to purify water is chlorine, and we are taught to use symbols. Then Roman number 2, an element which forms the atomic molecules. So group 6, 7, all these are the atomic molecules. So we can give oxygen, we can use nitrogen, we can use hydrogen, we can use even chlorine. All these are the atomic molecules. Roman number 3, an element which reacts with water to give an alkaline solution. So an alkaline solution is just the basic solution. So elements that behaves in such a manner are group 1 elements. So we have sodium, which is Na, can be potassium, any from group 1, or lithium. Then Roman number 4, an element which forms an ion of type negative. So whenever you see a negative, it means that element will gain to become stable. So we are looking at a non-metal, and since it's negative 2, these are group 6 elements such as oxygen, sulfur, selenium, all these are examples. Then B1, oxygen, sulfur, and selenium are in group 6 of the periodic table. At room temperature, oxygen is a gas and sulfur is a solid. Predict whether selenium is a liquid, a solid, or a gas at room temperature. So if you look at the periodic table, the way these elements are arranged, we have the first one, we have oxygen, followed by sulfur, then we have selenium, which is Sc. Then the trend of these elements is similar to those in group 7. When you go up, their reactivity increases. Now, we are told if oxygen is a gas, then sulfur is solid. What of selenium? Selenium will also be solid. That's a key point. So for non-metals, their states changes as you move up going down. So it changes from gas to liquid, then to solid. Then if you look at Roman number 3, the trend in reactivity of group 6 is similar to that in group 7, which is the one that we looked at earlier. Suggests the most reactive element in group 6. So it is oxygen because it is the one on top. So we just have to look at the one on top is the most reactive element in terms of group 6 and 7. Then we have question 5. Urea with this chemical formula and water are formed when ammonia reacts with carbon dioxide. Urea is obtained as solid from the reaction mixture. Okay. Roman number 1. Write a balanced chemical equation including state symbols for this reaction. We are given 2 reactants. The first one is ammonia. The second one is carbon dioxide. So we write ammonia, NH3 gas, plus carbon dioxide, CO2 gas as well. Then we have urea. We have been given NH2, then CO. Solid, we are told solid, plus what else? Water is also a product, so liquid. Now from here we need to balance this chemical equation. So the question is, how can we balance this chemical equation? Where are we supposed to put the numbers? So we'll begin with nitrogen, is the one that we are going to focus, because for carbon there is only one here and also one here. So the carbon is balanced. Now let's check for nitrogen. So now for this one, we have 2 atoms of nitrogen because inside here there is a 1. So whenever there is a 1, you multiply with this subscript here. So 1 times 2 is 2. So this means that in 1 molecule of urea there are 2 atoms of nitrogen. So we are going to put 2 here. So nitrogen is balanced. Now let's check for oxygen. for, hydrogen. So there is 2 here, 2 times 2 will give us 4. 4 plus 2, 6. 2 times 3, 6. Then our equation is now balanced. How many atoms of hydrogen are present in one molecule of urea? So the chemical formula for urea is given NH2, then enclosed in brackets CO. This formula can also be written as this: NH2 CO, another NH2. It's the same. So we have 2 amide of this in one molecule of urea. So from this you are able to see. So from the above you can just say 2 times 2, we have 2. Then from the one below here we can just say 2 plus 2. So there are 4 atoms of hydrogen. Okay, we move on to question B. What mass of urea in tons can be formed from 34 tons of ammonia? So we have some calculations here. So let's focus on urea. What's the chemical formula for urea? We are saying NH2 CO NH2. Then what mass do we have for ammonia? So we use NH3. So the mass, the one that we are solving for, is the mass for urea. So we put X here. Then the mass for ammonia is given 34 tons. So we are going to find the relative molecular mass for ammonia. So from the ammonia, there is only 1 atom of nitrogen times 1 plus 3 atoms of hydrogen. So the mass is 14 multiplied by 1. 1 times 3. 14 times 1 is 14 plus 3. 1 molecule of ammonia has the relative molecular mass of 17. Now if you look at the ammonia, we have 2 molecules. There is a 2 in front. So this number should be multiplied by this number here so that we get 34. So 34, we put 34 here. What else? We are going to find the mixture of the substance whose mass we are solving for. So let's look at this one. So we have mixture is equal to nitrogen times, we have 2 atoms of nitrogen, these 2 here. So times 2 plus what of hydrogen? It's multiplied by 4. Then carbon times 1 plus oxygen times 1 as well. Mass number for nitrogen 14 times 2. Hydrogen 1 times 4. Carbon it's 12 times 1. Oxygen 16 times 1. So 14 times 2 is 28. Plus 1 times 4, we have 4. Plus 12 plus 16. So if we add 28 plus 12 will give us 40. Then 40 plus 16 will give us 56. Plus 4 will give us 60. So we have 60. Then we cross multiply. So we have 34 times x is 34x. Then here we have 34 times 60. So I won't multiply because I know that the 34 will cancel. So the final answer is 60 tons. Okay, here we said this should add up to 60. Then we move on to question 6. So question 6, name 3 of the components of clean dry air. As long as there is clean, never include gases like carbon monoxide, carbon dioxide, sulfur dioxide. gases that may pollute the environment, so these must be excluded. Then what are these gases that forms the clean dry air? So the first one is oxygen, then we have nitrogen, then also argon is considered to be part of this. Then air can be polluted by various chemicals. Give the chemical name for one of these air pollutants. Now, whatever gas that you are going to choose for this one, you have to make sure that you are able to answer the rest of the questions. Like for Roman number 2 and 3, depends on the answer that you give. For example, if I choose carbon dioxide, we know that carbon dioxide causes the global warming. Then name the source of the pollutant mentioned. So the source, we can look at coal or maybe fuels. Then set the process by which it is produced. Then we look at this one as complete combustion. Okay, then what of carbon monoxide? The source is the same. Then here it's incomplete combustion. What of sulfur dioxide? The source can be also fuels. There are some fuels that may have this sulfur, or sometimes even the extraction of, if you look at the extraction of zinc and the extraction of copper may also be the source. Then if you look at the process, they are all produced by combustion. We move on to question 7. So question 7, start the diagram below on extraction of iron. Okay, so we have temperature 1400, 800 degrees Celsius, 400, iron ore, substance C and D. We have substance A on top, B hot air. Now let's look at the questions. So A, Roman 1, apart from iron ore, name 2 other materials C and D that are fed into the reaction chamber. So we have coke, chemically known as carbon, then and we have limestone, chemically known as calcium carbonate. We move on to Roman number 2. Write the balanced chemical equation for the reduction reaction of iron ore to iron metal. So out of the 5 reactions that we have during the extraction of iron from iron ore, there is the third reaction which is considered to be the most important reaction because it summarizes the extraction of iron, and this is the reduction. And this reaction involves the use of the reducing agent, which is carbon monoxide. So the equation is like this: Fe, 2 here, O3, then solid plus carbon monoxide reducing agent will give us iron solid plus the gas produces carbon dioxide. So extraction of iron can also be the source of carbon dioxide. So to balance this one, we have 2 atoms of iron, so we put a 2 here. Now for oxygen, we put 3 here, we also put 3 here, so that 3 carbon, then 3 here and also 3, we have 6, then here we have 6. So our equation is now balanced. Then we move on to question B. Name substances A and B. So A is the one on top, which is molten slag. Then for B, we have molten iron. State 1 physical characteristics of the brick lining in the furnace. So they are heat resistance. So heat resistance, they are made in such a way that they do not have the ability to lose heat. because of some of the combustion heat is very important. Then question 8, plastics are organic polymers. The table below describe 2 types of plastics. Complete the table. Part of the table has been completed for you as an example. Name, we have polyethylene. Repeating unit is just the monomer, so we want the monomer for polyethylene. So the monomer is ethene. Now, since we want the repeating unit, we can just draw it like this. So this is our repeating unit. Then use making plastic bags. Formation of such polymers, they are formed by addition then for this one we can say this is a pteridine, though they have the same structure as a protein. Then use to make nets. Okay, so now let's look at the 1 or 2 from this section. Okay, so we have question 9. Cesium, lithium, potassium, and sodium are all in group 1 of the periodic table. Place these metals in order of reactivity, starting with the most reactive. So if you go in group 1, we look at if you move up, if you move below, their reactivity series increases. So from this one, the most reactive is cesium, followed by potassium, sodium, the last one, lithium. Then we have question B. All group 1 elements react in a similar manner with water. Name the chemical products of the reaction between cesium and water. So we know that they will give us metal hydroxide. So we have cesium hydroxide. And the gas produces hydrogen gas. So that's a thing that you are supposed to master. Whenever a group 1 reacts with water, you get metal hydroxide and hydrogen. Then write a chemical equation for the reaction of cesium with water. Include state symbols. So cesium has the chemical symbol of CS, solid, plus H2O, liquid. Cesium hydroxide will give us this, which is aqueous, plus the atomic hydrogen gas. Where are we supposed? So let's just put a 2 here, a 2 here, and a 2 here. So our equation is now balanced. So we have 4 atoms of hydrogen, 4 atoms of hydrogen, 2 atoms of cesium, 2 atoms of cesium, 2 atoms of oxygen, 2 atoms of oxygen. Then for Roman number 3, write what 3 things would you expect to see if small piece of cesium were dropped in water in a glass trough. So the first one, we can expect to see bubbles. So bubbles are just the indication of the hydrogen gas, since we said we are going to have a gas here. Then apart from bubbles, we can have a colorless solution. Then what else can we see apart from this? So we can sometimes we can see some explosives, since we say that group 1 react vigorously, so sometimes we may expect to have explosives. Then question C, what is the other name for group 1 elements? So alkali metals. We move on to the last question. We'll look at question 10. Crude oil is an important raw material that we need in modern life. Engineers engineers process and refine crude oil in a tower to produce a number of fractions as shown in the diagram below. So we have this fractionating tower. Okay, then the first question, name the process used to separate the fractions of crude oil. Fraction distillation. Because this one has to do with a mixture of substances with different boiling point. Then question B, name the two major elements that are found in crude oil. So these are just the hydrogen and carbon. So most of these are just hydrocarbons. Then state two differences in physical properties between fractions extracted at C and at B. So this is our C, this is our B. So the difference in terms of position. So we'll say fractions at C have high boiling points than fractions at B. Then the other difference, since we have mentioned boiling point, we can look at the melting point. So fractions at C have high melting point than fractions at B. So for this one, if you look at if you move down here, the fractions below have high melting point, boiling point, including the density. Why? Because as we move down here, the number of carbons for each molecule increases. Then we have the last question. A large proportion of fraction A has the molecular formula of CH, which is methane. Write a balanced chemical equation for the complete combustion of compound with the molecule chemical formula of that. So complete combustion, we said we are going to have carbon dioxide and water. So it's a reaction that will give us carbon dioxide and water. Then our task is we need to write a balanced chemical equation. So balanced chemical equation, we put a 2 here, so that 2 times 2 will have 4 atoms of hydrogen and also 4 atoms of hydrogen on the reactant side. Then carbon is balanced. We're just going to put a 2 here. We can see that we have a balance. Then crude oil is a non-renewable energy source. Explain what is meant by non-renewable. So these are energy that cannot be replaced. Then give 2 reasons why the sun is a better source of energy than crude oil. The first one, it is clean, meaning it does not pollute the environment. Then apart from being clean, it is cheap. You don't have to buy, it is cheap. Then the other one, it is also renewable. So that's it for this video. Thanks for watching.